you guys were, in case you were wondering what it's normally like to have me as a teacher, it's usually just me like talking about nonsense, and then we do math for like 15 minutes. You know, COVID has taken the fun out of class, if you ask me. But I'm sorry. Let's get back on track. Okay, so if you're watching this video, pause it and write this down. Okay. This is our roadmap. I call it a choose your own adventure. It's a flow chart. It's all kinds of different, things. It's a visual aid that can help you process solving trigonometric equations. That's what we're looking at here. Okay? So it's a series of steps, but it's not step 1, step 2, step 3, so on and so forth. All right? Everything starts though with the idea that you have to have the same type of trig term. Meaning, if you see a cosine in the problem, everything should be a cosine. If you see a sine or a tangent, it should all be that. You can have sine squared and sine, that's okay. But you can't have cosine squared and sine. That's bad. Okay? And we'll talk about what to do with that. So there are some steps that go into this. Now we're going to take it real slow, real easy right off the bat. Okay? But just make sure this is true. Then ask yourself this question. Does the equation have a squared term and a non-squared trig term? And again, in the early going here, the answer is always going to be no. Okay? So then we would slide over here. So what do you do then? You use inverse operations to isolate the trig term. That means get that sine, cosine, or tangent by itself. And that may mean you have to take the square root. Then after you've done that and you've isolated the trig term, find the angles on the unit circle that have these values. Okay? We'll talk, what does that mean? Oops. Ah! I always forget this. I always forget to plug it in, guys. I do this 3 times a day, and I always forget to plug in the smart cord. There we go. Okay? Now, back at the end of Unit 4, when we were looking at inverse trigonometric functions, okay, arc sine, arc cosine, arc tangent, these are things that we talked about back then, okay? We can use those ideas here, okay? We can talk about taking the arc cosine of both sides. So what's going to happen, and I'm just giving you a preview, is we're going to solve an equation, and at some point it's going to end up looking like this. Okay? So when we get to this spot where the trig term has been isolated, ask yourself, or find the angles on the unit circle that have these values. Remember that cosine values, right? Actually, let's do it this way. Okay? Because this is an angle, that means the answer to our question is x equals, and we're going to get angle measurements for that. Because this is cosine, this represents an x coordinate. Okay? So this is an x coordinate. So we're looking for this x coordinate. When we were doing this with inverse trig, we said what pi value has an x value of radical 2 over 2. Okay? So again, here is my advice to you. If you're going to do this, if you're going to take this seriously, if you're going to do things the right way, when it comes time to do the homework for this, okay, have this written out somewhere on your desk, and have a unit circle somewhere on your desk. Okay? Because you have to have a unit circle, or you have to have it memorized in order to answer these final questions. So we're saying the cosine of some angle is radical 2 over 2. This is an x coordinate because we're doing cosine. Now, what angles have an x coordinate of radical 2 over 2? Right? Look at all these values. Look at all the x's. Here. Radical 2 over 2. So one of our answers is, and we're going to plug this in as a radian measurement, pi over 4. Now I don't want to jump too far ahead, but I'm not even going to go over here. Now, I don't need to look at these. Because over here, the x-coordinates are negative. I want a positive radical 2 over 2. So I'm not even gonna keep rotating over here. I'm just gonna stick on this side and see where that other angle is. It's down here. There's the other x-coordinate of radical 2 over 2. And that angle is 7 pi over 4. Okay? Now let's go to this other one. Suppose we're solving a trigonometric equation and we get to a certain point where it says sine of x equals -1. Because we're doing sine, again, this is still an angle, okay? So x is going to be the angle. Because we're doing sine, this is a y coordinate. So we're saying that if I take the sine of some angle, I get a y coordinate of -1. Where are the y coordinates negative? Down here. We're looking at y coordinates now, not x coordinates. So we would say the answer to this question is 3 pi over 2. So this is the end game. Okay? End game, end game. My daughter loves Taylor Swift. I'm sorry, that just popped into my head when I said end game. You guys like Taylor? You look like a Taylor Swift kind of guy. No? No? Okay, yeah, all right. That's okay. That's okay. We listen to a lot of Taylor Swift in the Jackson house. I'm sorry. But this is where we end up. Okay? We're going to have to do some stuff to get to here, but once we get to here, this is what we do. We look for coordinates on the unit circle that are associated with these trig terms. Okay? We'll do some examples here.